Hello all. In this lecture, we will see about NumPy module. So what is NumPy? So NumPy stands for Numerical Python. So it's a package for scientific computing in Python. So it's actually a Python library that provides a multi-dimensional array support. We'll see what is this multi-dimensional array and all. So it also contains various derived objects like master arrays, matrices. You can do this matrix operation and all using this multi-dimensional array. Then also it has routines for fast operations on arrays. You can simply add to matrices and all like in Scalar. You simply add a plus b. Like that, if you have two matrices A and B, you can simply give a plus b and you will get the result. So, and also it has packages for mathematical, logical, shape manipulation, sorting, selecting, discrete for Fourier transform, linear algebra, statistical operations. If you want to calculate standard deviation, mean, everything, all those scientific computing packages are available in this NumPy. So the core thing of NumPy is ndarray. So it is an efficient. So it stands for n-dimensional array. So it's an efficient multi-dimensional array. So n-dimensional arrays are of homogeneous data type. So it contains homogeneous data type. That means all the elements will be of same data type. So if you take all the in an n-dimensional array, all the elements will be of same type. That is, if you are creating some n-dimensional array, if you have for float values, then all the elements will be of float type. And also mathematical functions for fast operations and ndarrays without having to write loops. So we can do mathematical operations in a quick manner without writing any loops. And also it has tools for reading, writing array data to disk, and also for working with memory map files and all. So these are some of the features. We need not study all those things. We will study only some basic things of NumPy. So it is when we compare with this NumPy versus list, or the sequences that we have already studied, that is tuple, dictionary, and all those things we have studied. NumPy is very efficient on large arrays of data. And also NumPy internally stores data in a contiguous block of memory. That is, all the elements will be in continuous locations. That is, if the first element is in location, for example, if the address of the first element is 5000, then if it is occupying 8 bytes or 4 bytes, then second element will be at 5004, third element will be at 5008, like that it will go on. So NumPy internally stores data in contiguous block of memory, whereas list will not be in contiguous location. Maybe the first element will be in 5000 address location, second element may be in 6000, third element may be in 8000, like that it will go on. So since it is using contiguous location, NumPy arrays also use much less memory than built-in Python sequences. When compared to list and all, it uses less memory. And also NumPy operations perform complex computations on entire arrays without the need for Python loops, for loops. So if you want to do operations on list, if you want to add two lists and all, you have to use a for loop. But in the case of NumPy, you can directly add to NumPy arrays or ND arrays. So we will see these examples. That is how this uses less memory and all. I will show with an example. And also it is fast and flexible container for large data sets. So operations are fast also. I will show with an example why it is fast and all. Then it performs mathematical operations in whole blocks of data using similar syntax to the equivalent operations between scalar elements that I have already mentioned. So if you want to add two numbers, you will be performing a plus b. Similarly, if you want to add two matrices, you can simply write a plus b instead of writing for loops and all. So you have already seen how to add two matrices using list and all. There you have complex for loops and all. Here you don't need to use complex for loops and all. You can simply add two matrices by A plus B. So this is actually an n-dimensional array. So it is a two-dimensional array. This is a two-dimensional array because we have three columns, three rows and four columns. So first element will be A00, A01 like that, A02, A03. Then second row, first element will be A10, 11, A12 like this. So this is an example for ndarray. So this is an example for two-dimensional array. And this is an example for three-dimensional ndarray, which is of dimension 3. So it is dimensions of 3, and the shape. So this is shape is 3, 4. Here the shape is 3, 4, 2. That is, we have the axis 0. We will see what is this axis and all later. In axis 0, we have 3 rows, and in axis 1, we have 4 columns, and in axis 2 we have another 2 elements also. So it will be A000 like this, it will go on, A030 like this, A201 like this, it will go on. Then in the next axis it will be A001, then A002 like that, it will go on, and the final one will be A231. So this is an example for n-dimensional array. So you can store this much elements. If you want, you can have the shape as 4, 5, 6 and all. 4, 5, 6, 8, 10 like that. Any n-dimensional array can be created using this NumPy. Okay, now we will see some examples for this. Now we will see some examples. So what you have to do is you have to import the package. So for that, import NumPy. And I am using an alias, np. So I will be conveniently using this nps. You can use any variable name. Will be almost everybody will be using this np. So you have imported, and you can, instead of NumPy, you can directly use np now. Anyway, you can substitute this np. Now, if I'm going to create an array, a NumPy array. So this is just to show an example. That is, if you are using n-dimensional array, it is much more faster than list. When you are comparing with list, it is much more faster than list. So we'll learn how to create and all later. Now I am simply mentioning np.arrange. We will learn about this function and all later. So just to create an n-dimensional array, so I created an n-dimensional array with this number of elements. So this is how we can create element of this range. Then what I am going to do is I am creating a list also. So I want to compare with list. So I am creating a list, my list equal to. So this we have already seen. You can use the range function. So this is a range. This is for NumPy, and this is for ordinary list and all you can use. So I am using, so there are 6 zeros. Here we are using 6 zeros. It's the same number of range I am using here also. I am using 6 zeros. Okay. Now I am going to calculate the time. So what I am going to do is I am going to multiply all the elements by 2, and I am going to calculate how much time it will take. So just to show how much, how different is, how we can compare this n-dimensional array with this list. So percentage time for I in range of 10. I'm storing it. I'm going to multiply my ARR. And for this thing, you can simply, I've already mentioned that it's like scalar multiplication. You can simply multiply. So to multiply each element, you can simply do this thing. So my ARR, so you have created the n-dimensional array, and you are just multiplying it by 2, and you are storing it in my array. Okay. So the time taken to create this thing and to multiply by the 2 and to store it in that MIR is 66.9 milliseconds. Now I will do the same thing. I will do the same thing for my list also. So my list, but you cannot directly multiply a list. For that you have to use this. You have already seen list comprehension and all you have already seen. So I will be multiplying each element x by 2 for x in my list. So this way you can multiply now percentage time, and you can. So this is the wall time. So if you combine, this is 2.61 second. This is millisecond. This is just 66.9 millisecond. And if you make the same list and do the same multiplication, it is 2.61 second. So this is just to show that NumPy arrays are faster than the ordinary sequences or the list. So it is better than the list. Now you leave all these things, a range, all these things you leave. You will see all these things later. Okay. So this is how we can show that the wall time, that is the CPU time, is 66.96 for n-dimensional array. And the same operation, if you do, it takes more than it takes 2.616, which is very, very fast. So if you say it is more than 100 or 200 times faster than list. Okay. Now, how to create? We will see some examples on how to create n-dimensional array. So first statement is always you have to import this thing. Okay. So I've already imported. You need not import again and again. Even if you import again and again, it won't show any error message. So you have imported this thing. Now I'm going to create an NP array. For that, you can simply use array. So this is a function that can be used. So, and inside this, if you are creating a one-dimensional array, you can simply give 3 elements. So if you give 3 elements, and if you run this, and if you want, you can print this thing and see that now it has created a one-dimensional array. Only one row is there, so it is a one-dimensional array. So if you want to create a two-dimensional array, so if you want to create a two-dimensional array, then what you have to do is you have to replace this with then, and also you have to use here also. Then if you want to now I'll be using this thing. Okay, now you can, if you use this command, and if you want, you can print this A. You can see that is a two-dimensional array now. It contains 2 rows now. So it is a two-dimensional array now. So in this way, you can create arrays. So here we have created one-dimensional array, and you can simply print the A also like this. Then it will show that it is an array of this type. So it will give that array also here. Now, if you want, you can use random numbers. If you want to input the random numbers, you can use random function is available. So you have to import that. You have to use that package function np.random.array_ndn, and you can give any values. Now I have used this thing 2, 3. And now I have run this thing. Now you can print this data and see what all elements have been stored there. Now you can see it has created a 2, 3 array. So it is a shape is 2, 3. So it contains 2 rows and 3 columns. So that's why I give it 2, 3. Now if you want, you can use any dimension. So 5 comma 3. Now if you run this thing, and you can copy this thing. Okay. So you can see that it contains 5 rows and 3 columns. Now if you want, you can use another dimension also, 5 3 comma. So if you run this again, you can see that there will be, this is of shape 5 3 comma 4. So it just generates some random numbers and fills everything. So in this way you can have random numbers also. Now I will just reduce it. I will make it 3 comma 2 itself. Okay. So it has generated 3 comma 3 rows and 2 column array. Now what I'm going to do, I have already mentioned that it's simple scalar. It's like simple scalar operations can be done. So if you want to multiply the whole elements with 10, you can simply do this by data into 10. So you will get the value like this. So if all the elements are multiplied by 10. And if you want to add all these things, it is also possible. You can simply add. Now data is added with data. Okay. So in this way you can do all these operations. Now if you want to avoid this NP, you are always using this np.random and all. So if you want to avoid that thing, there is another way to avoid this thing, but it is not encouraged to do that. What you have to do is you have to use like this. Now you can simply, if you want to create something like this array or anything like this, you can. Or if you want to avoid this thing, NP can be avoided. So if you are using the same thing, you can avoid this thing by simply, you need not use that NP if you are using this thing. Now if you print this, you can see that it is still working. But it is not a good practice to do this thing. So I'm just removing these statements. So always use like this, import NumPy as NP and do like this itself. Okay. So you always practice use NP dot like that. So that is how we can, this is just an introduction to this NumPy. Now I have already shown that how it is faster than the ordinary list and all. So actually this NumPy, I have already mentioned that this creates a multi-dimensional container for homogeneous data. So if you see that all data is of homogeneous type, that is, it is creating a float type. So all the elements are of float type. So all the elements must be of the same type. So all the elements, so whether if you check any of these arrays, all the elements will be of the same type. And here array has a shape also. There is a shape for this array also. Now if you want to find the shape of that array, you can simply use data.shape. So if you want to get the shape of this data, you can simply type data.shape and you can run this and you can get the shape as 3, 2. So in this way you can get the shape of that. And also I have mentioned that it is of same data type. So in order to get the data type of that object, it returns a data type object. If we want to find the data type also, we can simply use data.dtype. Now it will return an object of D type. So float 64 is the data type of that object. So this is some basic of this ND array. Now I will show another example. I have already mentioned that it occupies less space than list. When compared to list, it occupies less space. So I will show with an example how it occupies less space. Now for that I am importing sys package. We have already seen the sys package in the previous lecture. Now I am creating a list of range of some 1000 elements, 10,000 elements. Now I am checking the size of this list. So in order to check the size, you can use this function called getSizeOf. There is a function inside this. It is getSizeOf. You can get any of these elements. So there are 10,000 elements. If you want to get the size of any of the elements, you can either use 0th element or it returns a size of one element. Now if you want to find the size of the whole element, you have to multiply with the whole length of that list. So I'll use LIS. Okay. So I am going to, so here length of len of list will give the length of the whole list, and this gives the size of any of the element. You can use any of the value if you want third value. So it gives the size of the third element. So that multiplied with the whole element will give the size of the whole element. So if you check this thing, okay, sorry, I have to use a list of. Just a minute. Just a minute. I will just delete this thing. So I will use it here. List equal to range of 10,000. Then what I have used is print of sys dot get size of any one of the element multiplied by length of the whole list. Now we'll create another ND array, arr equal to np dot a range of 10,000. Okay, now I'll print. So in order to find the size of one element, it will be arr dot size multiplied by arr dot item size. Item size. So if you you can see that this is the first size. For the list, it takes this much space, and for the n-dimensional array ARR, the size is just 40,000. So that's why we have mentioned that it occupies less size when compared to the list. Okay. Now we will see how to create this ND arrays. So if you want to create ND arrays, you can simply define like the same data 1 equal to, if I'm giving some values like 6.5, 5, 4, 3. So I have simply defined this thing, data 1 equal to. Now if I want to create an ARR1 equal to, what you have to use is the simple ARR array of data 1. Okay, ARR1 equal to np.arr. Now if you print this thing, you can see that this has created an array of a one-dimensional array. So this is created a one-dimensional array. Now if you want to create a two-dimensional array, you can simply use, I'm using another element, ARR2. Now I'm using another list here, data 2, comma, 8, okay. Just a minute, there's some I've used the comma. Okay. So this way I have created now ARR2 equal to the same thing you can use np dot array of data 2. Now if you print this, you can see that it is a two-dimensional array with 2 rows and 4 columns. Now if you check, everything has been converted to float. Even though I have given integer, everything has been casting. This is known as typecasting. It's almost automatically converted to float because I have already given a value 6.5. So all the values will be converted to the float. Now we can check the dimension. If you want to check the dimension, you can simply check ARR to the dimension. You will get the dimension as 2. Now if you want to check the shape also, you can check using ar.2.shape. So if you check the shape, it gives 2, 4. It is two-dimensional and the shape is 2, 4. There will be 2 rows and 4 columns. And similarly, you can check for ARR1 also. ARR1, if you want to check the data type, ARR1.data type, you will get the data type as it returns a float of data object. It is float 64. Now if you want to check the data type of the second array also, you can check 2.data type will give the second. So it is also a float 64. Now there is another way. If you want to create specialized arrays, like if you want to create an array which contains all zeros, so you can use np.zeros. So you can use this np.zeros of 10. So if you simply mention like this, it creates an array of zeros. So it contains a one-dimensional array of 0 elements with all initialized to 0. And you can similarly create two-dimensional also. If you want to create a 3, 4, it is also possible. So you have to use it as tuple. Okay. So this way you can create zeros arrays. And there is another way to create an empty set, but it is not good to use this thing empty. There is another way to create an empty set, empty array 4, 2 like this you can create, but the problem is it will be filled with garbage values. So it will be filled with garbage values. So sometimes it will be filled with zeros and sometimes it will be filled with garbage values. Now if you check, it is filled with some garbage values. Okay. So it is not good practice. So if you want to create zeros, you can use zeros, or you can use empty to create empty arrays. Now we will see the data type for empty arrays. We have already seen we can use this D type to find out the data type. Then when you create itself, if you want to mention that data type also, it is possible. So if you want to create an NP array, np.array, and if you are entering elements like 1, 2, 3, and if you want to specify the data type also, it is possible to specify the data type. Even though I have entered as integers 1, 2, 3, if we want to make it as float, it is possible by using np.float 64. By mentioning data type equal to float of 64. Now if you print this thing, you can see that it has been converted to float now. So this way you can create floating type. Now if you want to convert it into integer also, it is also possible. Now if I am creating with 1, 2, 3, then another, if you want to create as integer, then you can simply mention as int32, then that is also possible. ARR1, if you print this thing, you can see that it is an integer array. Then you can do casting also. If you want to convert it into particular data type, now it is actually integer type. Now if you check ARR1.d type, you can see that it is of integer type. Now if you want to convert this into floating array, you can convert it into floating. I will name it as array3. I'm converting it into float. So I'm converting ARR1 into the dot. As type can be used, as type. So as type, and you can convert it into float 64. So in this way you can convert into float. Now if you check ARR3.d type, you can find that it is of type float. Okay. Now I will use ARR1. Okay. So we have an array, B array is there. B array. I'll just print it and see. So it is some floating point numbers is there. If we want to convert it into integer, it is also possible. Now np dot int of int32. So what it does is it will truncate the decimal part. It will simply truncate. Even though it is 6.5 is there, it is truncated it to 6. So it is not a rounding off, it is actually truncating the decimal part. So all the decimal parts will be truncated. I will show another example. For example, if you want B, I will use this thing ARR. I will use this thing. I will show another example. I'm not giving any float values here. I'm simply giving some values here. I'm giving 2.8 and I'm giving 3.2 and here I'm giving 1.5. Okay. Now if I am doing the same thing here, I am converting it into float now. ARR1 is converted to float. Integer type. Now this is actually float values. Now I am converting it into float. Now if you check this, it will be actually truncated. So all the decimal part will be removed. So even though it is 2.8 and all, it is not rounded, it is actually truncated. So that's all about creation of NumPy arrays. Thank you.